Alright guys, so welcome back. It's been a little while, but we're gonna start doing our recorded video again. Like, I won't necessarily play these in class, but I'm definitely gonna use them as a resource during class, just so that I have. What I'll do is I'll put timestamps in the description for every time I finish a page. So like this page for my 30, 60, 90 triangles, whenever I get done with it, when we get down here and whatnot, I'll lift up the camera. It'll be full page, and I will timestamp each individual page, and during yeah, that way you can refer to them easily. I'll refer to them easily during class, and then you can watch this full video if you need the actual explanation. Okay, otherwise you can just go ahead and check the link in the description. I'm so sorry. Check the description for all the different timestamps for each individual page of notes, okay? Just so you have something to copy if you need it. Now, we're going to be doing this in class, so I probably don't even know if I'll be showing this or not. You're probably not going to hear any of this explanation, but for those of you that either missed class or for those of you that just need a little more clarification, we're going to go ahead and do all that work right here. Okay? Now, what you can do is you can find the sine, cosine, tangent, cosecant, secant, and cotangent of any given value. You already know that. Okay? So remember, we are basing it off of our SOHCAHTOA. So SOHCAHTOA. And I told you don't really need to learn the second one, the Choshikau. It's the CHO. Let me get my orange marker. I'm gonna put this down here, but we're not actually gonna use it. CHO, sha, cho, sha, cow. There we go. Sorry about that. So again, you really don't need to memorize one because if you only know one of these, if you know SOHCAHTOA, then you don't need to know the other one because it's just the flip version. So it really doesn't matter that much. I'm going to be working off of just SOHCAHTOA, and then I'm just going to flip all of my answers to get my results. But we're going to take this first one slow, and then I'm going to do all the other ones a little bit quicker, okay? So we're just going to start with our initial value of 30. We're just going to do the sine, cosine, tangent, cosecant, secant, and cotangent of 30. But I'm going to walk you through every step of doing this, okay? You do have to do something called rationalizing denominators, which you talked about during class. I suppose I could make a video of it. I'll ask you guys later, see if I need to make a video on rationalizing denominators. But anyway, let's go ahead and start with just the sine of 30, okay? This is your initial value. And again, I just started off with the lowest angle. It really doesn't matter which one we started with. Um, yeah, it just doesn't matter. So let's go ahead and do the sine of 30. So sine of 30 is equal to opposite over hypotenuse. And remember, with your ratios, okay, so these are your ratios of a 30, 60, 90 triangle. Across from 30, you've just got your smallest angle, or x. Across from 60, you've got x root 3, and then across from the 90, you've got your largest value of 2x. Okay, so if we're taking the sine of 30, the opposite angle, which would be opposite or across from it, would be just that x. Your hypotenuse, your hypotenuse is always the longest side, and it's always that side across from that 90-degree little square. So if we draw a line right through our square, we'll end up over here where the 2x is. So 2x is your hypotenuse. We could actually simplify this. X will cancel out with x, and you'll just get 1 over 2. So the sine of 30 is 1/2. And if you grab a calculator and type in sine 30, you will get 0.5 or 1/2, depending on what your calculator is set to. But you will get this value. Okay? So that's why, when you guys have seen me during class doing certain problems quicker and whatnot, it's not because I know or I'm so fast at math, it's just because I already learned this stuff. So you guys are just doing it the slow way. Once you get good at this, it gets a lot easier. So there's your sine of 30. Let's go ahead and do our, so I could move over to cosine, but I'm just going to go ahead and do the reciprocal of this. So remember this reciprocal just means we flip this fraction. You're also going to get your cosecant. So here's your cosecant of 30. And you could do this calculation, h over o is equal to 2x over x is equal to 2, but I'm just going to take this 1/2. Remember, we flip it. You'll get 2 over 1 or 2. All right? See, the cosecant of 30 is 2. Now let's go ahead and do the cosine. I'm so sorry. Yes, no, that's right. So let's go ahead and do the cosine. Cosine of 30. Cosine of 30, remember, is your a over your h. That's adjacent over hypotenuse. So your adjacent, let's go ahead and look over here. Here's your 30. Your opposite angle is over there. Your adjacent angle is right next to it. It's touching it. So it's at x root 3. Your hypotenuse is still 2x. That hasn't changed. In fact, none of your values will change. And now we can do some simplification. That x and that x will cancel out. You'll just end up with root 3 over 2x. Oh, I'm so sorry. The x is canceled. What am I doing? Root 3 over 2. Okay, so the x's cancel out, and you just end up with root 3 over 2. If you type that in a calculator, you'll get some decimal. I don't actually have that memorized. I should have memorized it, but give me one sec. So if you type that in your calculator, you will get 0.866, which I told you guys around in the second place, 0.87. So root 3 over 2 is 0.87. And remember, this doesn't matter what values I use. If this is a 30, 60, 90 triangle, if it is, even if I write that this is 30 or 50 or whatever else, which is the examples that I've given you in class, okay, so if you take a look at your example in class, I use actual numbers for these. No matter what my numbers are, they're going to end up as root 3 over 2 and 1/2 for these two values. For all of my values, they're going to end up exactly the same no matter what these numbers are, if it's a 30, 60, 90 triangle. Okay, so let's go ahead and do another one. Oh, that's right. So let's go ahead and do the opposite. I'm so sorry, the reciprocal of this. So this will be the secant of 30 is equal to, remember it's h over a, all that jazz, but I'm just going to take this value, flip it. Here's where that rationalization comes in. So I told you we can't have that radical in the denominator. We learned that same thing with imaginary numbers. So we're going to rationalize this denominator. You're just going to multiply it by itself, root 3 over 3. All right, and then you'll just write these next to each other. 2 times root 3 is 2 root 3. All over root 3 times root 3 is the square root of 9. The square root of 9 is 3. So this one is 2 root 3 over 3. All right. This is actually an important value. Well, I'm sorry. Pretty much all of these are important values, and we will certainly get to them. These are all going to apply to your unit circle, which will be in the next video, not this video, because that'll just be... in fact, the unit circle video is going to be like 4 or 5 different videos too. So I'm going to break it up so it's a lot easier to handle. Remember, timestamps will be useful. They are your friends, so check the description whenever we're done. All right, cosine, secant, and now let's go ahead and do tangent and cotangent. So tangent of 30. By the way, there's not a particular reason that I keep capitalizing my T's in tangent. I think it's because it's so close to my name that I'm used to capitalizing a T, but they don't have to be capitalized. They can be lowercase. It really doesn't matter. I just keep capitalizing my T's out of habit. So the tangent of 30, somebody asked me about that yesterday. Or not yet. I don't remember. Somebody asked me about that. Anyway, so the tangent of 30, remember, is your TOA. Oh, sorry, TOA. So your opposite over your adjacent. And so let's go ahead and name our opposite and adjacent again. Your opposite again is still x. Remember, none of these values have changed. Your adjacent is still x root 3. Your x's will cancel out, top and bottom, so they'll cancel out. You'll get 1 over root 3. But here's the problem. That's right. You notice there's a radical in the denominator, so we have to do that thing we just did called rationalizing. You're absolutely right. There you go. So let's go ahead and rationalize this. All right. So again, we'll multiply by itself, root 3 over root 3. So 1 times root 3, you could write it like 1 root 3 if you want. I'm just going to write root 3 because anything times 1 is itself. But anyway, so root 3. And then remember, square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. And that would be your tangent of 30. Okay. After you've done tangent of 30, we can go ahead and flip it, and we will get our cotangent of 30. Cot of 30. And remember, again, you can do adjacent over opposite, that whole process. That's fine. I'm just going to flip this 3 over root 3. And remember, we can have that radical in the denominator, so let's go ahead and rationalize again. Root 3 over root 3. And then 3 times root 3 is just 3 root 3. Root 3 times root 3, you guys should be noticing a pattern. It's just going to be 3. And 3 divided by 3, they're going to cancel out, and you're just going to end up with square root of 3 as your final answer. Okay, so let me get all this on one page real quickly. All right. Sorry about that. There you go. So this is this entire page. I'm going to go ahead and timestamp this in your description below, but you can get this whole page, and it describes all the values of all your trig values of 30. Okay, and we can do this with 60 as well. Like I said, I'm going to do these other ones slightly quicker, but I'm still going to do them. That way we have them. But during class, I'll also give you guys a table. So I'm going to give you guys a couple of things. I'm going to give you a unit circle, and I'm going to give you a table that includes all of these values, just in case you just want to memorize them. So it will be in a table format as well. Okay, so that's the sine through cotangent of 30. We're going to do the same thing with 60. Okay, so let's do the same thing with 60. Maybe you guys are getting bored of the blue. We'll go ahead and switch over to orange. All right. So remember, we're still using a 30, 60, 90 triangle. I guess I'll just draw another one actually. So here you go, 30, 90. And this is x root 3 to x. We're still using, I had green earlier. I'll just do it in blue now. So, toa. All right. So we're still using all the same things, but we're just going to do these numbers with 60 instead. So you guys should be pretty good at this by now. But sine of 60 is equal to, remember sine is still opposite over hypotenuse. Nothing's changed. But we do have different values. So remember your 60 is up here now. So if your 60 is up here, your opposite is no longer x. Your opposite, remember, you just draw a line straight through it. Whatever line you cross, that's that value. So that's x root 3. X root 3 all over your hypotenuse is still 2x. So hypotenuse is going to change no matter what our reference angle is, but the other values will. They'll just switch places. It's not really that bad. So now we'll just go ahead and finish this calculation. The x's will cancel out, and you will get root 3 over 2. What you'll notice, by the way, is that that happens to be the same, let's see, as the cosine of 30. Cosine of 30 is root 3 over 2, but the sine of 60 is also root 3 over 2. Don't let that stress you out right now. If that's confusing, go ahead and forget it for this particular second, but I just wanted to point that out because you'll notice that a lot of these values are exactly the same. Or, all, not all. No, yeah, let's go with a lot. That actually makes sense. I think that was a good sentence. So, a lot of these values are exactly the same. They're just for different values, and you'll learn why when we go over unit circle. I promise all of this has like a point and a reason. It all kind of ties in together. Math is funny like that, but it'll take us a little while to get to there. So just bear with me through this video. Again, I'm going to do this a little bit quicker. So the cosine, or I'm sorry, the cosecant of 60 is again h over o, so we're just going to flip this to over root 3. You have to go ahead and do that rationalization. So when you have 2 over root 3, we have to multiply by root 3 over 3, root 3 over root 3, and you will get 2 root 3 over 3. All right, which is another value that you may recognize. So let me go ahead and bring this back over. So this one's the cosecant of 60 is 2 root 3 over 3. Earlier we found that the secant of 30 is 2 root 3 over 3. So you'll kind of notice that they're opposites, right? So this was sine 60, root 3 over 2. This was cosine of 30, root 3 over 2. So sine versus cosine. This one was cosecant versus secant. And you can probably guess that when we do the next value, so we did sine, we did cosecant, we got these two. When we do our cosine and our secant, we're probably going to end up with those two. I'm not saying we will. Well, whatever. It's not a surprise. It's math. Nobody cares, right? So it's not a surprise. Anyway, it's going to happen. So let's go ahead and do these other two. Cosine of 60. I have no idea why I tried to keep that a secret from you guys. Like it was going to be some kind of like birthday surprise. Nobody cares. So yeah. My God, that was weird. I don't know why I did that. Sorry about that. Okay, so the cosine of 60 is going to be the adjacent over hypotenuse. Okay, and again, remember your angles of change. Why does my desk keep shaking? All right, so remember across from your reference angle, we're looking for our adjacent. It's just x. Okay, adjacent over our hypotenuse 2x. The x's will cancel. You'll just get that this is 1/2, which I told you guys is the same as your sine 30. Sine 30 was 1/2. Cosine of 60 is 1/2. Okay, and again, this next one will turn out to be 2. I won't keep it a surprise. I suppose I'm tired. Anyway, let's go ahead and move on. That's the secant of 60 is equal to h over a, which is now going to be this flipped 2 over 1 or 2. All right. Almost done, almost done. Two more. So let's go ahead and go with the tangent of 60, and the tangent of 60 is O over A, opposite over adjacent. Remember, your opposite is going to be now x root 3. Your adjacent is x, so x root 3 over x. The x's will cancel out. You'll just get root 3. Earlier, you found that the cotangent of this value was root 3. But now it's the tangent of 60 is root 3. So this was cotangent, this one's the tangent. So we're going to do the cotangent of the next value. You would think that it would match your tangent value. Maybe you don't notice this pattern, that's okay. Again, I'm really not trying to keep secrets. Anyway, so your cotangent 60, we're just going to flip this. So this is like root 3 over 1. Oh, sorry, let me move this out of the way. So this is like root 3 over 1. So we're going to write this as 1 over root 3. But we can't have that, so we have to do our root 3 over 3. Root 3 over root 3, and you're just going to get the square root of 3 over 3 as your cotangent 60 value. So you'll notice here again, tangent of 30, root 3 over 3. Cotangent of 30, root 3. Tangent of 60 on the, oh man, I wrote in my notes. Tangent of 60 on the other hand is just root 3. And then the cotangent of 60 is root 3 over 3. So they flipped. And then all these other values, your sine flipped with your cosine. Sine 1/2, cosine 1/2. Cosecant, secant, etc., etc. So you'll notice that there is a direct correlation between your values of 30 and your values of 60. Okay, so we did our sine, cosecant, cosine, cosecant, secant, cotangent of 30 and 60. There is one more value that I want to do this with before I end this video, okay? We're going to do the same thing, but it's just one more value. And remember, we're going to do it as quickly as we did here, maybe a little quicker. These values will be new, okay? So 30 and 60 are related because they're on the same triangle. But this next one's a little different because it's on a different triangle. You guys memorize this one as well. Here's your 45, 45, 90 triangle. And your 45, 45, 90 is an isosceles triangle. The ratios are as follows. I did this one in blue. So the ratios are x, x, and x root 2. So like I said, this 45 one is going to be slightly different from the other two, but it's actually a little easier. The calculations just work out a lot nicer. But and they're also easier to memorize, so it's not too big a deal that they're different because they are by nature easier, but they are on a different triangle, so they are different from yours 30 and 60. Okay, so we're going to do the same thing again. So, ka, toa. The only reason I keep writing it down is so that everybody keeps seeing it and it drills into your head. Like, yes, by now a lot of you guys are probably sick of SOHCAHTOA. Actually, I don't know. Some of you guys seem to like it. Whatever. I don't know. I personally am sick of it. I don't really like thinking about it. I always did mine a little differently anyway. So let's go ahead and do this again. Let's do sine of 45 is, remember, your opposite over hypotenuse. But now your values are different. Your opposite, and speaking of which, they're both 45, so it doesn't matter which one our reference angle is. I'm going to go ahead and make it this bottom one just for argument's sake. So your opposite would be x, and your hypotenuse is x root 2. So you'll do the math, the x's will cancel, you'll get 1 over root 2, but you cannot have that radical in the denominator, so you have to rationalize it. You'll end up with root 2 over 2, okay? Root 2 over 2, which would mean that your cosecant of 45 is going to be the flip, 2 over root 2. But again, we'll rationalize this denominator as well. So you'll multiply by root 2 over root 2. And you'll get, well, 2 root 2 over 2. 2's will cancel out. You'll just end up with the square root of 2. All right. So that's sine and cosecant. Let's go ahead and do our cosine value. Cosine. You'll notice something interesting here as well. So your cosine, remember, is adjacent over hypotenuse. But what is your adjacent value? Still x. Your hypotenuse is still x root 2. So you'll notice that x over x root 2. You'll notice that your cosine of 45 and your sine of 45, despite the fact that they're opposite and adjacent, because your opposite and adjacent sides are exactly the same, these are exactly the same. So you actually don't even have to bother with the calculations because if you know sine 45, you know cosine of 45. That's why I said that this one's a little easier to memorize than the others, just because all the values kind of work out really nicely. Like you don't get a whole lot of change in here. You even get some ones, so it's kind of nice. Anyway, so let's go ahead and do the secant. So again, because we have the same exact values, remember they're just going to flip. But when we flip them, if they're the same as sine, they're going to be the same as this one. So we actually just repeat the cosecant value, and you'll end up with root 2 again. Okay? So sorry for those that were, or I'm sorry if that was too quick. Let me go ahead and explain what that was again. So remember, our sine of 45 and our cosine of 45 are exactly the same. Both are root 2 over 2. Because they're exactly the same, the flip or the reciprocal is going to be the same. So 2 over root 2, which would mean that the secant of 45 is also 2 over root 2, which you already did the calculations for to get root 2 here. So that's how I got that. Okay? Let's just go ahead and do one more value, and I told you guys it's turn out really, really pretty. This is the easiest one to memorize, so this is the tangent. Ooh, I actually did that one lowercase. I don't know why. I must be being hyper conscious of it. I'm not really sure. That's really weird. Anyway, is opposite over adjacent. Let's go ahead and name our opposite and adjacent values. What you'll notice is your opposite and adjacent, we already talked about it. They're exactly the same. X over X. Anything divided by itself is 1. And there's that really pretty number that I told you would come up. The tangent of 45 is 1, which means that our cotangent, by the way, of 45 is, so the reciprocal of 1 is 1 over 1 or 1. The reciprocal of 1 is itself. So nothing special happens there. So these are all of your values for 45, 45, 90, which is why I told you that despite the fact that they're on a different triangle and fundamentally, oh, let me get it all on screen. There we go. They're fundamentally different from your 30, 60, 90 triangle. The values themselves are actually easier. So this is probably the easiest triangle to memorize, while the other two are a little bit weirder. Just because these look nice. Square root of 2, root 2. Square root of 2 over 2, root 2. 1, 1. Like you really only have to memorize 3 different values and you've got the whole thing. Okay? So let me go ahead and, oh yeah, these will all be timestamped in the description. So go ahead and use that for these 3 pages. So we did our sine of 30, well, I'll just call them trig functions of 30. So we did our trig functions of 30, trig functions of 60, trig functions of 45. As long as you can do these 3 things, you have what you need to calculate the inner side of a unit circle. We're going to go over more about that in the next video, but I'm going to go ahead and stop it here. That way this video doesn't get too long. Anyway, good to be back. Good to get this all working out again, and we'll definitely get you guys through trig. I promise you it's all going to make sense. It's all going to wrap together. You just got to be patient with me while we go through the little individual parts. I'm so sorry. I know that it just feels like you're learning random things. I promise it all comes together at the end. All right? Thank you guys so much, and I will see you guys tomorrow. Bye.